Test. And we're live. Welcome everyone to another stream of Ventures in Kubeland. If you're new to this is a stream that is happening every Tuesday, 9:30 CT. And in this stream, we're exploring Kubernetes and all the CNCF projects. Tonight, or today, depending on where you are, we're going to look at OpenTelemetry. If you're new to OpenTelemetry, we're going to see what OpenTelemetry is. We're going to start from a perspective of someone that never used it, and then explore the website. And if we have time, the stream usually lasts 1 hour. We're going to look at how to use it and possibly implement one service that expose at least one metric. But I don't want to spoil too much. Let's see where we get and how far we can get in 1 hour. So I'm going to transition to my user setup in a moment. You're going to see what I'm looking at, what I'm talking about. So what I usually do during those streams is share my desktop. And in this case, we're going to see, I usually have a terminal and a website. For tonight, we're going to have an editor. In this case is Visual Studio Code and the website on the other side. As I say, we're looking at OpenTelemetry. OpenTelemetry presents itself as high quality, ubiquitous, and portable telemetry to enable effective observability. The OpenTelemetry technology, I don't know if I want to call it technology, it's probably a set of tools. It's a collection of tools, API and SDK, was born as an effort of standardizing the telemetry data and the cloud native application would send out. So as they say, OpenTelemetry is a collection of tools, API, and SDKs used to instrument, generate, collect, and export telemetry data, metrics, logs, and tracing to help you analyze your software performances and behavior. OpenTelemetry is generally available across several languages and suitable for use. So what does it mean available? I mean, available across several languages. OpenTelemetry offers library that you can use to instrument your code, and is supported by the following languages. Now, supported, we will see that what the support is, and you can already see by the table that there is not all the support that you think there may be, but let's go through the website slowly and see what we can get. OpenTelemetry code instrumentation is supported for languages listed below. Depending on the language topic covered, will include some of or all the following: automatic instrumentation, manual instrumentation, exporting data. If you're using Kubernetes, you can use the OpenTelemetry operator for Kubernetes to inject other instrumentation libraries for Java, Node.js, and Python into your application. So that's another interesting behavior you can implement if you're on Kubernetes. We're gonna look at that in a moment, but let's keep going through the languages. The current status of the major functional components of OpenTelemetry is the follow. So you can see that traces are the more stable or the more widely supported, right? OpenTelemetry started covering traces. In one of the recent podcast that we've done with Dan, a friend of mine, my friendly head of data and analytics engineer, we discussed why tracing, and we think that is mostly because there was the unsolved problem, or one of the unsolved problem. We already solved metrics and logs, maybe not nicely as we would like them to be solved, but at least we had something implementing metrics and logs. While for tracing, that was still quite difficult, especially in a world where microservices became the norm, and so, or at least became one of the more maybe overused term. And also we were moving into the fully function implementation. So you go with lambdas or Azure functions and so on, right? So the more you split your code, the more you distribute your code, the more traces or distributed traces became important in order to understand what your application was doing. So, but I mean, let's leave it at that for a second. Let's keep going through what this says, right? So stable, beta for PHP, Python stable, Ruby stable, and Swift. Rust is embedded and Swift stable. So right now, I would say that C++, C Sharp, or .NET, Erlang or Elixir, Go, Java, JavaScript, Python, Ruby, and Swift are a safe bet when talking about traces. But if you move into metrics already, you will see that, well, for C++ and C Sharp, this is stable. Erlang is experimental. Go is in beta. Java and JavaScript are stable. PHP is also beta. Python is stable. Ruby is not yet implemented. Rust is in alpha, and Swift is experimental. And this is the one that is probably more behind in terms of implementation. I don't know if the specs are well defined, and that's probably something we're gonna look at next. But it's probably, yeah, it's not stable for any of those, right? There is experimental for C++, Erlang, Java, in development for JavaScript, alpha for PHP, experimental for Python. So it's interesting that, for instance, for Go is not yet implemented. And what else? Ruby and Rust. Rust is quite behind in terms of telemetry. I didn't realize this when looking at the code quickly. So again, you can actually follow those links and you will find that there are libraries for you that you can use, and there are details on how to use them. Getting started, so there is the full guide on how to integrate this with your language, and this is probably something that we're going to do later on the stream. So stay with me, probably at the half hour or at the top of this hour. We're gonna try to implement something with this. But now let's go deep, as I say, right? We want to look at what this does. Okay, this is get started with OpenTelemetry based on the rule. I remember going through this in the past, and what it shows you is, if you are a developer, how you instrument your code. So you develop software, your goal is to get observability by writing code, and you want to have a dependency emit OpenTelemetry for you automatically. But if you are an ops instead, you run and set application in production, your goal is to get telemetry out of them without touching their code, and you want to collect traces, metrics, and logs for services and send them off to your observability backend. Makes sense, right? Different roles, different responsibilities. So if we look at the concepts, we're gonna see that, okay, the key concepts here is observability primary. First time I hear about these core observability concepts, signals, components, semantic conversion, instrumenting. Maybe we're gonna look at this later because I don't see huge value going deep on some of those. But if we look at maybe other things like the case for, I wanted to look at the specs to see what we are at with them. So on the spec, you will see that there is the glossary, and then there's the API specification, the SDK specification, and the data specification. So one thing that I'm curious of, I've seen some details about the metrics, the tracing, sorry, in the past. I'm curious about the logs and metrics, but let's have a look at the protocol for a second. Design goals, interesting. So let me go back. I want to go straight to the logs, maybe. Okay, logs data model. This is a data model and semantic convention that allows. Let me zoom in for a little bit, because I'm not sure that you can read this. Can someone in the chat tell me if you can read it or not read it? Allows to represent logs from various sources: application log file, machine generated events, system logs, etc. Existing log format can be unambiguously mapped to this data model. Reverse mapping from this data model is also possible to the extent that the target log format was equivalent, has equivalent capabilities. The purpose of the data model is to have common understanding of what a log record is, what data needs to be recorded, transferred, stored, and interpreted by a logging system. This proposal defines the data model for standalone logs. What is a standalone log? Standalone log records that are not embedded inside a span and are recorded elsewhere. Yeah, okay, but then you have to follow up and see what a span is. So we're not going to do that for now. Design note requirements. The data model was designed to satisfy the following requirements. We're going to narrow down a little bit now, but to me, it's very interesting to understand what is the logic behind defining a logs data model. It should be possible to unambiguously map, and in fact, we lost a viewer there, ambiguously map existing log format. Just to be clear for the people that are watching, this stream is mostly to learn new things, right? I'm not here to gather following or anything like that, although it's not a bad thing, right? I'm not judging who does it from there, but I'm here to learn new things. If you want to learn with me, follow along. It should be possible to unambiguously map existing log format to this data model, translating log data from an arbitrary log format to this data model and back should ideally result in identical data. Okay, interesting. Mapping of other log format to this data model should be semantically meaningful. The data model must preserve the semantic of particular element of existing log format. Translating log data from an arbitrary log format A to this data model and then translating from data model to another log format B ideally must result in a meaningful translation of log data that is not worse than a reasonable direct translation from log format A to log format B. Okay? It should be possible to efficiently represent the data model in concrete implementations that require the data to be stored and transmitted. We primarily care about two aspects of efficiency: CPU usage for serialization, deserialization, and space requirements in serialization form. This is an indirect requirement that is affected by the specific representation of data model rather than the data model itself, but is still useful to keep in mind. The data model aims to successfully represent three sorts of logs and events. System formats. There are logs that are events generated by the operating system and over which we have no control. We cannot change the format or affect the information is included unless it is generated by an application which we can modify. An example of system format is syslog. Third-party applications that are generated by third-party application, we may have certain control over what information is included. Example, customize the format. An example is Apache log file. First-party application. Those are applications that we develop and we have some control over how the logs are and events are generated and what information we include in the logs. We can likely modify the source code and application if needed. So definitions used in the document, blah blah. The document will refer to types any and map string of any, defined as follows. Type any. Value of type any can be one of the following: a scalar value, number, string, or boolean, a byte array, an array, a list of any values, and map string any. Map where the key is a string and the value is any. Type mask string any. Value of type mask string any is a map of string keys to any values. Yes, so as I say, right, keys in the map are unique. Duplicate keys are not allowed. The representation of map is language dependent. Arbitrary deep nesting of value for array and map is allowed. Essentially allowed to represent an equivalent of a JSON object. Fill kinds, okay, that's too much. Log and event record definition, timestamp. So Appendix A contains many examples that show how existing log format map the field defined below. If there are questions about the meaning of a field, reviewing the example may be helpful. Here's the list of fields in a record log. Timestamp, observe timestamp. Time when the event occurred. Time when the event was observed. Okay, interesting. This is already something very nice to see. Trace ID, span ID, W3C trace flag. What is a W3C trace? Okay, that's something that I'm gonna have to look up. Severity text, the severity text also known as log level. Okay, so the log level became severity text. Interesting. The severity number, numeric value for the severity, body, the body of the log record, resource, describe the source of the log, instrumentation scope, describe the scope that emitted the log, attributes, additional information about events. Below is the detailed description of each file. Okay, timestamp, we know what this is, right? It's going to tell you that it's probably in 64 nanosecond, okay, whatever. Observed timestamp, time when the event was observed by the collection system for event originated OpenTelemetry using OpenTelemetry logging SDK. This timestamp is typically set at the generation time and is equivalent to timestamp for event originating externally and collected by OpenTelemetry using collector. This is the time when OpenTelemetry's code observed the event measured by the clock of the OpenTelemetry code. This field should be set once the event is observed by OpenTelemetry. For converting OpenTelemetry log data to format that support only one timestamp, or when receiving OpenTelemetry log data by receipts that support only one timestamp. Recipients. Recipients that support only one timestamp internally. The following logic is recommended: use timestamp if it is present, otherwise use observed timestamp. Okay. So what it's saying is that if we receive a log that doesn't have a timestamp, then we still have the observed timestamp, and that is the fallback in case timestamp is not present. Makes sense? Trace content field, trace ID, span ID. And okay, now there is a link in here. The trace ID is the ID of the whole trace forest. It's used to uniquely identify a distributed trace through a system. It is represented by a 16-byte array, for example, blah, blah, blah. All bytes are 0 is considered an okay, so all 0 is considered an invalid value. The trace ID value is invalid, for example, if it contains not allowed characters or zeros, vendor must ignore the trace. Okay. Span ID can be set for logs that are part of a particular processing span. Span ID is present, trace ID should be also present. This field is optional. Trace flags. Trace flag is as defined in the W3C trace context specification. At the time of writing the specification defines that one flag. Okay. Severity field. So we right now know that when you translate a log from whatever system you have to OpenTelemetry logs, the log level becomes severity text. That's news to me, but hey. And then you have the severity number. And if you look at these, there are ranges. So numerical value of the severity from normalized to values described in the document. This field is optional. Severity number is an integer number. Smaller numerical values correspond to less severe events, such as the bug events. Larger numerical values corresponds to more severe events, such as error and critical events. The following table defines the meaning of severity number values. 1 to 4 is a trace. 5 to 8. So I'm interested to know why there is a range in here. Smaller numerical value in each range represent less important severe log events. Larger, okay, more important, we already see this. For example, severity number 17 describe an error that is less critical. Okay, that's fine to me, but why? Mapping from existing logging system and format must define how severity represent numerical value. If the source format has more than one severity that matches a single range in this table, then the severity of the source format must be assigned numerical values from that range according to how severe the source is. Information, reverse mapping. Too much. Error semantic, okay. Trace. So in this case, what is happening is that we have different, I see, okay. There's in this short name to describe the 4. Is it always 4? Yes, so it's always 4. I didn't notice that, or at least I didn't pay attention to this. but it's 1 to 4, then it's 5 to 8, and then it's 9 to 12. And so you have, okay, info, but it's interesting that they don't do info 1, they do info 2, info 3, info 4. That's an interesting thing. Okay, that's too much. And then, yeah, but that's interesting. It's interesting to see what they do, right? So I think the important part in here is that we want to focus on the fact that there are some default values that you have, and those are the one defined up here. So those are the metadata that are important while looking at this, right? The body is the default log, so that is easy. So that is the specification for the logs. Now I'm curious to see the metrics if there is something similar, right? And I suppose that for the traces, what it's going to tell us is that we're going to use the W3C traces format because it's already there. The metrics data format. Oh wow, this is a lot of stuff. Shall we? Okay, what time is it? 52. We said at the top of the hour we were going to see an example implementation of these. So let's maybe go through this real quick, and then in 8 minutes we're going to see if we can implement something with this. So the OpenTelemetry data model for metrics consists of a protocol specification and semantic conversion for delivery of pre-aggregated metric time series data. The data model is designed for importing data and existing system and exploring data into existing system. Importing and exporting, as well as to support internal OpenTelemetry use cases for generating metrics from streams of span or logs. Popular existing metrics data format can be unambiguously translated into the OpenTelemetry data model for metrics without loss of semantic or fidelity. Translation from the Prometheus and StatsD exposition formats is explicitly specified. The model specifies a number of semantic preserving data transformation for use of collection price supported flexible system configuration. The model supports reliability and statelessness controls through the choice of cumulative and delta transport. The model supports cost controls through spatial and temporal regression. Interesting. The OpenTelemetry collector is designed to accept metrics data in a number of formats, transport data using the OpenTelemetry data model, and then export into existing systems. The data model can be unambiguously translated into the Prometheus remote wire protocol without loss or features or semantics. Through well-defined translation of the data, including the ability to automatically remove attributes and lower historical resolution. Oh, that's interesting. That is very nice. Event data stream time series. So status table. The OTLP metric protocol is designed as a standard for transporting metric data. Describe the intended use of this data and associated semantic meaning. OpenTelemetry metrics data stream types will be linked into a framework containing a higher level model about metrics API and discrete input values, and a lower level model defining the time series and discrete output values. The relationship between models is displayed in the diagram below. Origin event model, in transit output stream model. Okay. I think I'm gonna go very deep on these after this stream because this intrigues me. OpenTelemetry protocol. There are a lot of details in here, and I believe that no matter what you do in the software industry, this reading may be pretty interesting to understand how events can be aggregated, for instance, how to represent data in time. Okay, this is something that I'm going to definitely share with some other colleague or engineer. But look at the size of this document. So definitely we don't want to spend the next 5 minutes reading this because it's going to definitely take more than 5 minutes. So let's play a little bit with OpenTelemetry. Let's see. So what do we want to do? We say that we can start instrumenting something. Um, let's see what the languages are. Definitely not C++, definitely not Erlang or C Sharp. I can go with something like Python, Java, Python, JavaScript, or Go. And which one we say that can be auto-instrumented? Definitely Node was there. Java, Node.js, Python. But let's maybe go with Python just for the sake of it. So if let's say I'm in here and I want to start a Python project, what do I do? Oh man, I forgot that Python needs pip. So Python is going to be a nightmare for dependency, isn't it? Python 3.10. We have Python 3.10. Can we use, do we have piphemb? Sorry. We do have piphemb. There you go. So what do they say? Do they say to start a new piphemb environment? No, they just go on and say install this thing. But if I do piphemb, I don't remember the command of piphemb. It's been some time since I started a new piphemb. Okay, so piphemb blah blah 3.7. We need 3. So yes, let's do 3.7. I'm okay with 3.7. 3.7. So we're gonna, okay, let me also zoom in on this because I don't know if this is visible. And what does it say? 3.7 is not found in the system. To install Python. So what do we do? Pyem. What if I do what we were 3.10 we say, right? Let's go with 3.10. Is it possible to go 3.10? Yes, it is. And then we do pip install OpenTelemetry. Why cannot copy this? I should probably copy this. Come on, Luca, you can copy and paste this fine. There you go. OpenTelemetry API. Let's give it some time. You can see that the pip file was already created here. Yes, and packages is not persisted yet because if I remember correctly, you have to run the freeze command in order to persist the packages. So if I do piphemb and then freeze, is it freeze? Nope. What was the command? Piphemb. Lock is not what we want. Oh, it doesn't matter. Generate the requirements doc. There you go. Requirements. Piphemb requirements. No such file directory. Oh, because it needs the pip file lock. Okay, we don't need that at the moment. In addition, there are several extension packages we can be installed. So if you're just following now, we're trying to create the first software using OpenTelemetry. And I went with Python because why not? In addition, there are several extension packages that can be installed separately. We don't need, those are for exported and instrumentation packages respectively. The Jaeger, Zipcane, Prometheus, OTLP, and OpenCensus exporter can be found in the exporter directory of the repository instrumentation. Additional exporter can be found in the country repo instrumentation. Okay, let's go here. Okay, so if I do OpenTelemetry exported Prometheus, that's what we want, I suppose. So I don't know. It's not like I have Prometheus somewhere for now, but let's see. Prometheus. And you know what? Let's install Jaeger as well because I think Jaeger is easier to set up. So let's do this, or at least to run standalone or in Docker. That is something that we've done the other day. Our last stream. It's not public, but I can probably make it public if I clean it up a little bit. Then there are extensions. No, let's go to the meaty part. there are some functions that have not yet been released in PyPy, and I don't care. Getting started. Okay, less than 5 minutes. Do we have 5 minutes? Ooh, we have 30 minutes. Get telemetry for your app in less than 5 minutes. This page will show you how to get started with OpenTelemetry in Python. You will learn how you can instrument a simple application automatically in such a way that traces, metrics, and log are emitted to the console. Oh, wow. So we don't need a backend. Great. Requirements, obviously, right? That's something that you want to do when you are running stuff locally. The following example uses a basic Flask application. If you are not using Flask, that's okay. You can use OpenTelemetry Python with other web frameworks as well, such as Django or Fast API for a complete list of libraries for supported framework. You can see, I don't care, right? For more elaborate examples, see examples. Installation, make dir, cd, python-m, virtualenv, activate. I don't know all of that. I want to install Flask. Let's install Flask. Man, it's been some time since I used Flask. And then we're going to create a file in here, new, app.py. And then we do, and now I'm not going to copy and paste because I love writing this code. Random import run int from Flask. It's been some time since I wrote some Python. App equal Flask Discord name, and then we're gonna create a app.root slash, what do we do? Roll dice. Of course we do roll the dice. That's why we're importing run here, aren't we? Dev roll dice, and then return str or do roll. Oh, come on. Okay. And then def do roll. It's gonna be return run dir run int 1 6. It's fine. Save these. Run the application with the following command and open localhost whatever to roll the dice. Yes, but that is not gonna. Well, it's actually gonna work because. Okay, so when you run these, this is gonna be exposed on my. What happened? Yes, Flask is not part. Flask is not installed. Why is it assuming that Flask is installed? Did I run the? Okay, Flask is not installed because. Oh yeah. Let's do something else. And ppamp. Let's actually use the because we're not in the ppamp, I believe. So let's do this and use their example. Again, as I say, it's been some time since I used, so I probably didn't activate the ppamp. So we're gonna do what they say to do. They want to use Python 3 VM. Oh wow, they created some folders. That's why this is gonna work. Then we're gonna go back and install the OpenTelemetry libraries. I don't think those will be installed by default. But if I do these, now if I do Flask and sorry, pip install Flask again. Now the Flask command should be then on my path. I can even do this, it's fine. Or at least it should be fine. pip install. La, la, la. Yes, I've done this. If I do this, I was saying this will run. Will it? Boom. Cannot import Flask from Flask. But I installed Flask, didn't I? That's why I don't know. I misspelled it. Obviously. There was a typo. Open the browser. And there you go. So this is gonna probably fail because I'm in the wrong. Why will it fail? I don't know. Let's see. Will it fail? Yeah. And now if I do roll dice, slash roll dice. There you go. Now we get the dices. That's nice. Instrumentation. Automatic instrumentation will generate telemetry data on your behalf. There are several options you can take, covering more details in automatic instrumentation. Here we'll use the OpenTelemetry instrument agent. Install the OpenTelemetry package, which contains the OpenTelemetry API SDK. Oh my god. Okay, and also the tool OpenTelemetry Bootstrap and OpenTelemetry instrument you will use below. So let's do these. Let's stop these. Let's install OpenTelemetry distro. Lots of things happening in the background, I assume. And then run the OpenTelemetry Bootstrap-a install. And this is all here, right? Let's see what is inside. What is this? We're learning the Bootstrap. Okay, Bootstrap is a Python code that is gonna run what? Bootstrap import run. Okay, it's gonna run it. Interesting, interesting. Okay, done. This will install the Flask instrumentation. Run the instrumented app. You can now run your instrumented app with OpenTelemetry instrument and print and have it print to the console for now. Copy. So OpenTelemetry instrument traces porter console, trace metric is porter console, log is porter console, Flask run. Why is it 5,000 now? Well, okay, default is 5,000. That's why. So let's go. Oh, look, already something. Let's go 5,000. Roll dice. 5,000. Yes. Boom. What do we have in here? Okay, this is good. I've done nothing basically, right? So that's the reality. I didn't add a single thing. It did the other instrumentation by itself. He added the code. That's pretty interesting. What do we get though? Is there anything useful that we get out of this? So I know that I got to roll dice, the context, the trace, kind, start time, 20 to 2008. Yes, this is UTC. End time status and set attributes. Oh wow. Get port. We get a lot. Yeah, we get a lot. Resources. Python SDK name, SDK version. Nice, nice, nice. So those are nice metadata. And resource metrics, scope metrics, active request, number of measure the number of current. Oh, nice. So we get some nice metrics out of these as well. The duration. Interesting. The aggregation temporality. Fine. So let's see if I can run some nice test on this. So let's open another console in here, and I can run like curl. I don't like these, but let's see. 1,000 roll dice. I mean, he's a poor man. I can even refresh in here because I didn't have to do that. But see, the exporter, there you go. The exporter is probably sending data, especially the metric exporter is sending data every now and then. So it's collecting the data, aggregating, there you go, it's the term that I was looking for, and then sending the data. That's very interesting. Okay, so it looks like that I didn't have to do much in order to start these. Let's see what else yes, let's see what else but this is wrong, right? This is open localhost 8080. 8080 seems to be not the right one, unless there is something still running on 8080, and that's why you fold back into a different port. Let's see. No, there's no, oh, maybe my port, it's busy, but no, because when I ran these, it was okay, right? When I was doing these, this was okay. No, it's interesting that when you run it without that, and you run these, Flask run, that goes to 5,000. So maybe that's up here that we can open. So let me do one thing. Flask run default port. There you go. Change port. Okay, the default okay, see, the default one is 5,000. So this code, this page is wrong. Wrong. Shall we tell them? How do I do this? Today we may do a little bit of a contribution. We either change the command and we add the -p 8080 like this, and then you have it 8080. So let's maybe do that. Let's see, documentation. Usually there is a nice link to the how to edit this documentation. How much do we have? Well, we have plenty of time. We can definitely change these. Last modified to set up on port number. What? Okay. Okay. Pull request. Are we fixing that? 8080 or 5,000? No, there is nothing like that. So let's go back on that pull request. With this, we know that this is the file that we want to change. And so if I look at these, copy, it's in content, English, docs, instrumenting, Python, get it started. Getting started, Python. Instrumentation, blah, 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 Python, get it started. There you go. Find Flask run. Here you go. So part of these, we can probably do something like edit this file. And we're gonna have to look at what is the contribution policy in here. Oh, I'm not sending, sorry. I was going to do this, but I forgot that in this browser, for this stream, I'm not sending. But you know what? We are gonna do this. I promise that we're gonna do this. So a nice contribution is gonna be this one. I'm gonna save this for me and be sure that I contribute back right after the stream. So lesson learned, stream, go through the documentation, test things, and if you find an error, please open up here. The next person is gonna be very grateful. Maybe there's already did we check if there was an issue? Yeah, I think that's what we checked, right? Issues 5,000. Nope, there is no issue. So usually on those projects, what you want to do, you don't want to open up a request right away that is contributing, but you want to find the problem. If you find the problem with the content of this repo, you should like to request an enhancement, create an issue. So you should first create an issue. Oh, wow. Okay. But then you submitting a change. Yeah, so you want to read this before submitting the change. So that's what I'm going to do. promise I'm going to do that after the stream. So stop. Actually, maybe tomorrow since it's getting late in here, but let's keep going. Next step. Where were we? We were up here. There. After all, you should see the span printed in the console, such as the following. Yes, we've seen this. Yes, we've seen that. The generated span tracks the lifetime of a request to the roll dice route. Send a few more requests to the endpoint, and then either wait for a little bit or terminate the app. You'll see metrics in the console output, such as the following. Yes, we have seen this as well. Version temporally, scope metrics. We've seen measured number of concurrent HTTP requests. This is very nice. Add manual instrumentation to automatic instrumentation. Automatic instrumentation captures telemetry at the edge of your system, such as inbound and outbound HTTP requests, but it doesn't capture what's going on in your application. For that, you'll need to write some manual instrumentation. Here's how you can easily link up manual instrumentation with automatic instrumentation. Traces. First, modify app.py to include code that initializes a tracer and uses it to create a trace that's a child of the one that automatically generated. Okay, so let's see. From OpenTelemetry, import trace. Okay, and then you want me to define a tracer equal trace.get tracer, and we're gonna call it dice roller tracer. Up is fine, that's fine. Do roll. Yes, on the do roll, what we're gonna do is with tracer dot start as current span to roll. Start as current span to roll as roll span. Then what do? We assign the random integer. So res is going to be response is going to be equal to this, and then you do roll span dot set attribute. Interesting. Where is going to this is going to be in the value equal res. Oh, interesting. So in the current span, we're gonna set a new wow. Let's see if this works. A new value, a new attribute. Sorry, that's the word that I was looking. Nope, there is an error somewhere. Get greaser. Where did I get greaser? Get tracer. It's not greaser. Run again. Okay, now we're talking. So let me close these. Let me close these and let's do dash p. Apparently this is more than just the first one. And opening browser. Of course, it's opening on my default browser. There's another window that you don't see. That's why I need to copy and paste these. But if I go to roll dice 4, 5, blah, blah, blah. So in theory, on one of those, we will see the roll.value on the attribute. Attribute, is this the one? No. Let's see if we can find it. Attribute in the current attribute. And where do we do it? In the start do roll. Attributes roll.value equal to, and I suppose that later on there's going to be the equal 3, right? Because do roll value 1, do roll, where is it? Do roll value 5. Come on, how many times I rolled? In any case, the last one is going to be 3. So that what we're doing here, we are basically creating a new metric with a value that we define, an attribute that we define. Interesting. That's nice. This is nice. And they can respond. There is the parent ID. There is we're going to be able to visualize all the rolling that we've done with the current value. Something that we didn't suppose before, right? Probably, to be honest, probably wasn't the response of some of those. I'm not even sure if there was in the response, but this is nice. Right now, definitely we have more or additional information. We still have 9 minutes. Let's see what we can do in 9 minutes. Again, probably gonna open up here for this as well, because I suppose that in this case you gonna have the same error. Metrics. Now modify app.py to include code that initialize a meter and uses to create a counter instrument which counts the number of rolls for each possible roll value. Oh wow. Okay. Number of rolls for each piece. So how many times each number has occurred, right? That's what we're saying. So meter, obviously we were sending traces before. Metrics x dot get meter. Dice roller dot meter, and from OpenTelemetry import. Otherwise, we're not going to be able to use the metrics. There you go. Where is the dice roller? What is acquire meter? What is the dice roller dot meter? Am I blind? Acquire meter, dice roller dot meter. Okay, I'm not sure how that's gonna happen. There is some magic going on. Roll, or I'm missing something very obvious. Counter equal meter dot create counter. Please don't make typos. Counter. We don't have time for typos. Description equal the number of rolls by roll value. Look at me. Okay, save, and then when you scroll down, because now we have to count them, right? That's not it. So we are res, it's fine. Roll span set attribute is fine, and then we bump the counter. Roll counter dot add 1 on roll dot value res. Okay, and then you return the res. Again, we run again. It's gonna fail. Of course, it's gonna fail, and it's gonna fail because that roll is not defined. Obviously, it's not defined. This must be a string. Another thing that we can fix. Look at me. Gather some contribution today. And there you go. We roll the dice. I see some red. Hopefully, it's nothing too bad. Okay, yeah, that's fine. And what do we get? Roll value. Where is the counter? Give me the counter. And I need to find the counter. Obviously, having this size, do roll, status code, attributes, roll value, roll dice. Let me see what I need to expect. Resource metrics. And is it there? I don't see it. So let me try to refresh it a couple of times and see if that is the problem. Okay. Come on. Context. Come on. Resource metrics. I don't see the resource metrics in here. Wait. Ah, metrics exporter is there. Did we run it with metrics exporter? Now that I think about it. Yes, metrics exporter is console. So if we do, let's try to zoom out a little bit. I want to see if that is there. I don't want to scroll too much and maybe lose it. Scope metrics, roll counter. Here you go. It was there. Look at this. The number of rolls by roll value. And then you have data points, roll value 6, value 3, roll value 5, value 4. So it was there. Nice. Send telemetry to OpenTelemetry collector. This is something that probably we can do next time. But to be honest, you can see how easy this is, right? You can actually do this fairly easily. Especially with the other instrumentation. I would guess it may get a little bit trickier if you don't have this nice auto instrumentation functionality, that is injecting code for you, I would say, something like that. Otherwise, it's a fairly simple thing to do. Let's run another bunch of requests real quick. If you run these, then you're gonna see that there is gonna be some metrics exported. Come on, give me the metrics. Give me the metrics. Oh, it's not there yet. Scroll down. Okay, I'm gonna stop these and we're gonna see it. There you go. And this is the result. Metrics, roll counter, and you have all the rolls. Okay, so that's all for today. We have a bunch of PR to open, mostly to fix the port, but also to fix this typo in here. That didn't convince me, and in fact the quotes are missing. Thanks a lot for watching, and before saying goodbye, I want to remember everyone, this is the OpenTelemetry episode of the Adventures in Kubeland. Adventures in Kubeland is a stream that happens every Tuesday night, or every Tuesday at 9:30 p.m. CT, where we explore Kubernetes and the CNCF projects. Today we looked at OpenTelemetry, and if you're watching this on YouTube, please like and subscribe. This is going to help spread this stream. If you want to learn with me, join me next week. We're going to probably go deeper in OpenTelemetry and see what else we can do with this. Thanks a lot for watching, and I'll see you next time. Bye, everyone.